everyone. Thank you so much for checking out the 7th episode of the Weaviate podcast. Today, I'm joined by one of the heroes in deep learning, Brady Neal, who has made an amazing course explaining causal inference. He's had Joshua Bengio come on his YouTube channel to explain the latest ideas and things like System 1, System 2 thinking, the consciousness prior, and what causal inference might be adding to deep learning. Brady is currently the founder of Oogway AI, a decision-making AI startup, and he's also a PhD student at Mila. So Brady, thank you so much for coming on this podcast.
Thanks for having me, Connor.
So to kind of tip it off, could we get into just right away, what is causal inference and what does it add to deep learning?
Yeah, so causal inference is essentially you're trying to infer the effects of your actions. What are your actions causing? And I guess the way it could be related to deep learning is, so they're not necessarily competing. So you can use deep learning in causal inference. There's basically you might use machine learning models to help you do causal inference, and deep learning models are a good kind of machine learning model. And then there's also some insights for how causal inference can help out with topics that deep learning people care about. So for example, deep learning people care a lot about out of distribution generalization or compositionality, that kind of stuff. And there's some causal inference insights that can help out there.
So could we start with this idea of compositional generalization in causal inference? Is this where, so say we've seen things like disentangled representations, where say you're trying to have that low dimensional vector representation be interpretable as high level variables, and maybe you're trying to draw causal pathways between these high level variables. Is that kind of the thinking around what causal inference brings to that kind of dimension of you can compose novel configurations of the high level variables, and then having, say, the directed acyclic graph pathways helps you like structure the compositional testing? Is that the right way of thinking about it?
Yeah, I think that's a very good way of thinking about it. So like one way a lot of people, or at least maybe a few years ago, would think about disentanglement was this sort of statistical independence between these variables, right? That means that these variables are independent. They don't affect each other at all, which is like kind of weird. If you think about objects in a scene and you see like two balls and one hits the other, it affects that one. So yeah, I think it makes more sense to think about disentanglement as you're disentangling out the factors in this causal graph. So like one ball and two balls in the scene, then maybe there's like a background or something in the scene, and then you can draw arrows for which ones affect each other and which ones don't and such. Yeah. But so yeah, I think that's a good view of disentanglement, is figuring out the causal graph and the variables in the graph.
So do you think, so say with these generative adversarial network architectures, how we have a random noise, say in like the latest style GAN framework, they start off from a fixed representation, and then you have the random noise that comes into the pathway and it hits those intermediate kind of layers. Is that a good example of, say, this unobserved phenomenon that you model in causal inference, where say with these randomized control trial diagrams, how you have some unobserved factor of variation that you kind of work into the model? Is that similar to injecting noise and intermediate activations for deep neural networks?
Yeah, okay. So I'm not sure. So this recent style GAN thing, I'm probably not familiar with it, but I can imagine what you're talking about, injecting noise into layers of the network. That almost, to me, is almost like, you have this function that you're learning, and you're like injecting noise in parts of the function. That's how like I think of that. Yeah, so I don't know if I'm familiar enough with it, but if people haven't like explicitly stated that they're trying to capture causal relationships and stated it in more than a way, like in NLP, you see the phrase causal language modeling. That doesn't mean like what we mean in causal inference. That just means they have like ordering to stuff. But so yeah, if they haven't said it that way, then I'm guessing they're not trying to capture causal relationships.
Yeah,
so I'm not so familiar with this recent style GAN thing.
Could we stay on this this causal language modeling that you just mentioned, seeing that? So what is the so I guess the current thinking is because you're using the leftmost context to predict the rightmost mass token, you say it's causally, the left is causing the prediction of the right, but is that maybe not a honest interpretation of that causal phrase?
Yeah, well, I get how people read from left to right. So I guess I can see how they're thinking about it as causal, right? Like as you're reading from left to right, your brain might be predicting the next words or something, and those words that's predicting are a function of the previous words because you're reading from left to right. So it's like causing you to predict the next words in your brain. But in terms of objects in a story, it might be that the cause is mentioned later in the sentence where the effect is mentioned earlier.
So is that more akin to, say, like named entity not like named entity recognition, but that task of assigning labels to each token? So you would say label this token as a cause token and an effect token. Would that be like a more way to bridge the gap between NLP and causal inference?
Yeah. I guess yeah, that could make sense. You train a named entity recognizer thing to to get the cause and the effect. It's yeah, and then you have a data set, right? Where you try to do that. That could make sense. You would have to have a model that looks both ways, right? You actually wouldn't want to have a causal language model, I guess, right? You would want it to be able to have the future and the past context in the sentence.
So once you have the cause and effect labeling, should you map these tokens into one of these symbolic DAG graphs that, like, would distilling your model's predictions into one of these graphs be something that can maybe facilitate explainability? And then want to get into counterfactuals next, but do you think that kind of distillation between maybe if you first fit your training data set and then on your, maybe even just within the same training data set, you go from the cause effect labeling and you distill what it's predicting or what the representations it's learned into these symbolic DAGs. And then the DAG is the thing that you run inference with because you can look at it and say, okay, I can see the pathways that are causing this prediction.
Yeah, so I actually haven't. There are people who do research on causality in text, but I'm not that familiar with it, and I think a lot of it ends up being like sort of propaganda kind of research, right? Like how effective was actually, yeah, I don't know. I'm not totally sure on that stuff, but yes, you could take text and then try to figure out what are the the relevant variables that make sense to attend to, and then those are your variables in this causal graph, and you could model causal relationships described in the text. I've never done something like that before, but I could see someone do it. Maybe there's a paper that does that kind of stuff. In terms of explainability, like causal graphs, I definitely think aid explainability. Like anytime someone's asking a why question, you could potentially reframe it as like what caused this. There's a why this, well, what caused this? And so causal graphs, you can have the thing that you're trying to explain, and then there's these proximate causes, the things that are closest to it that have caused it. And then further down in the causal chain, there's things that cause those proximate causes, right? And so the phrase, I'm just using terminology here in case people want to Google it, but so there's proximate and then there's like ultimate causes, where it's essentially that's the stuff at the very beginning of the causal chain. But usually you can take causal chains very far back. And yeah, so I kind of lost where I was going with that. Oh, explainability, right? It was on explainability. And so you can discuss explainability at various layers in the graph. You can discuss it. Well, here was 10 days ago versus here was like 1 day ago. So say you're trying to explain COVID stuff, then those time ranges, there's different time ranges that make sense to look at and stuff.
So we've seen a lot of interesting things on, say, unifying structured and unstructured data, where what you do is, say, you go through the table and you parse it into natural language. Do you think going through, so you create some kind of causal structure with the proximate and ultimate causes. Do you think maybe having some kind of parser that turns those into natural language phrases and then just go ahead and language model those phrases, do you think that kind of distillation from the causal model to the language model could be a useful path?
So is it, let me make sure I try to understand. So you start with a causal model, and then you want to produce some language thing. What is the point of language thing? Is it to like explain the causal model, or?
Yeah, so you maybe traverse it and then annotate and then say like X had this impact on A, which caused this impact on B, and you
Oh,
but then you phrase it as a natural language sequence and just add it to the training data.
I see. So you have some causal model, and you could potentially generate many different sentences that follow that model, like right, like these. It's like having a grammar, I guess, and they're generating a bunch of stuff that follows the grammar. Yeah, that makes sense, and then you could use that as data.
So in this kind of thing we're talking about now, I think mostly trying to understand how we go from maybe this kind of idea of observational causal inference, where we try to discover causal structure in, say, an internet scrape of text data. And then there's kind of like, I guess, the experimentation side of causal inference. And you touched on it quickly, this idea of text as treatment. And I've seen these papers where, say, like the propaganda studies where they're studying how different ways that you the different styles of text that you use to present news, the impact of that as a treatment. So it's like A/B testing, but directly using text and representations of text to be the treatment. Have you seen these kind of studies, and do you think that kind of stuff is interesting?
Yeah, yeah. There's a word for this, right? Like there's some phrase where it's like you frame it this way, and then people overwhelmingly answer yes, and then you frame it a slightly different way, but it's the same meaning, and people overwhelmingly answer no. I forget what the phrase is for that. There's some term in like psychology for this. Anyway, but yeah, that stuff's really interesting, right? They're essentially doing an experiment where what they've held constant is the meaning of the say they're doing a survey. They've held constant the meaning of the survey question, which is like controlling for factors, right? Causal inference, roughly, you could think of as just controlling for factors. People have probably heard that phrase before, maybe doing it in a fancy way, but it's controlling for factors. So they've controlled for the meaning, they've held that constant, and then they're just changing the phrasing. So the idea is just the phrasing is enough to have very different impacts on people's psychology, right? Their understanding of the question or of the statement.
So with that idea of trying to, use the causal inference to take action and use a particular kind of text to influence people or whatever the setting is, what's the difference between structuring that as a causal inference problem or structuring that as a reinforcement learning problem?
Yeah, well, so I haven't thought a ton about the relationship, but I've thought a little bit, right? So reinforcement learning, you're essentially trying to figure out what actions you can take to maximize reward, whatever, or utility, whatever your the thing that you want, right? And in causal inference, you're kind of doing the same thing, right? You have some outcome that you care about, and you're trying to get the best outcome. You're trying to, well, if you're doing it prescriptively, if you're doing causal inference to decide what action to take, like what decision to make, then you're trying to figure out which action to take the best out to get the best outcome. And I guess it's just that in reinforcement learning, it's more you have all these trials where you can like experiment a bunch. Maybe in continual learning where it's like only one go, right? You when you die, it's the end. It's a little bit different. But in reinforcement learning, in normal, you have so many trials, you can die infinitely many times. So you can really test out like everything given enough time. And so I guess causal inference, maybe you could view it as like trying to be a bit more efficient with the actions you try out, and what is the information you're using to do that. It's like thinking about the causal structure of the problem. What are the factors that could be confounding my actions and outcome, and that I need to control for to get a better guess at what action might be the best action at a given point.
Yeah, it makes me think about, say, model-based reinforcement learning, where you're trying to learn the transition dynamics as well as how to act in it. And I think maybe with the causal structure to learning your world model is a more like you have the explainability, you have the high level variable compression, but then you still kind of need to go from the high dimensional observations into the high level variable space, right? So maybe things like self-supervised learning, and how they say one paper is curl, where they do contrastive self-supervised learning with the observations to try to facilitate that representation. And then from there, we can maybe construct these high level variable models for our dynamics and our transition models. So once you have these transition models, can you just unroll a counterfactual by just proposing some kind of action, or is it because it's out of the distribution space that the model is just going to compounding error? And maybe causal inference adds something to that idea of counterfactually querying your learned transition model.
Yeah, so counterfactuals here being like, what would the, or even maybe potential outcome is a more intuitive word in this context. Like, what would the result be if I were to take a given action? The potential, or what would the outcome be? What was the potential outcome? So yeah, if you have a perfect model of the world, you can just run the dynamics of that model and change the different actions, and you'll see which actions will produce better things. And that's basically what reinforcement learning does when it's run in a simulator, where the simulator is taken as the world. They basically have that. Yeah, and then counterfactual, just to clarify some terminology a little bit, like when I use people use terminology differently. When I use counterfactual, it's like, so you start off with two potential, or infinitely many potential outcomes, as many actions as you have, that you have a potential outcome for each one of those actions. And then once you take an action, like say I take a pill, then I realize that potential outcome, the outcome when I take the pill, and then the other action, like don't take the pill, becomes a counterfactual, right? So it's counter to fact. I can no longer observe it unless you have a model of the world, right? So we actually, I have a blog post on this. So a blog post and a paper. So you, if you have the model of the world, then you can observe all counterfactuals because you just run them through your model. Yeah, a blog post on this, and then there's a paper called Real Cause that helps people essentially observe counterfactuals. And there's various work where people use deep learning to try to get at counterfactuals.
So maybe from this, one of the early examples in your course of sleeping with your shoes on, and that leading to whether you've woken up hungover or not, or whether it's really because you've been drinking. If you unroll those into sequence, so it's like several of these decisions, could you take me through what it takes to generalize that kind of thinking into, you have five potential, like it's not just shoes or drinking, it's, I don't know, whatever leads to going out, like call from your friend or something like that.
Yeah. Okay. So you're talking about a sequence of actions, and then okay. So say you have a sequence of actions, and then the outcome is whether you wake up with a headache or not. Uh, yeah. Yeah. So for people unfamiliar with this example, it's just like the idea is that you notice that people who go to sleep with their shoes on often wake up with headaches. So it must be that when you sleep with your shoes on, they cause you to have a headache. I like amusing examples, is why I chose that example. But it's really just there's some confounder that's causing both of them, which is like you went to sleep drinking. And so, okay, so you're talking about, that's one action, is go to sleep drinking, but maybe there were actions that preceded that one. Yeah. So you could think about essentially like the picture I have in my head is a tree, right? Like Wait But Why has this nice tree diagram where, so like this is you at a given point in time, and then this is one path of actions. That's where you'd end up. This is another path of actions, another path. And you can view it as like a tree of many paths branching out every time you take an action. And then, so in that example, you kind of followed one path that ended up at going to sleep drinking, but you could follow other paths there. And each it's like the butterfly effect thing, right? Where one thing long ago could have an outsized effect on what, say, whether you wake up with a headache or not, right? Like if you decide to take a nap in the middle of the day, or maybe no, maybe that's a bad one. I don't know. Anyway, if you get put into a coma, right, then you're not gonna wake up with a headache because you got put into a coma a year ago and it's like a long coma.
So that kind of reminds me of, say, the like the mu0 Monte Carlo tree search of rolling out several pathways and then trying to pick from the pathways. And to me, that's kind of an interesting example of a neurosymbolic AI system where the Monte Carlo tree search rollout is like a symbolic program that you layer on top of your neural program. Do you think causal inference is like the way to bridge these neural predictions with some kind of symbolic reasoner, and is that kind of the maybe the best way to be applying it in with the current state of deep learning tools?
I think that if you ask a lot of causal inference people, they'll say yes. But whatever people are most familiar with is the tools that they want to use. So I mean, causal inference is useful for just when you're trying to infer effects of actions and you don't already know those effects, right? Like if you have a simulator or a accurate model of the world, which is like very hard to have, right? But if you were to have that, then you don't need causal inference really. Or I mean, you could say that the causal inference is just running the thing through your world model. That's you doing causal inference, and you've kind of pre-done all the work of adjusting for confounders by building that world model, I guess. But yeah, so always the question is, should we use causal inference to build up that tree?
Yes, so the question is just kind of about this, again, this bridging between just neural predictions and then some kind of symbolic program. And I'm thinking about whether it's about just this general concept of distilling your representations into this kind of tree. So I don't know whether you can, and then the connection of, because the connection between A to B, or like, did I drink beer last night? Did I take a nap in the middle of the day? With these vectors, it seems also kind of hard to connect them. I'm kind of just trying to imagine this, how to construct these causal inference pathways from these vectors, and then how to kind of traverse potential causal pathways when you're trying to like trying to make an inference on your learned world model, or you're still kind of building it, I guess.
Yeah, well, okay, so I'll try to separate a few different parts of causality out. So say you a causal graph, right? Variables and arrows connecting the variables, saying which variables cause each other. That's the kind of picture to have in mind. Learning the edges or the arrows of the graph, like what causes what, is called causal discovery, and machine learning people have been mainly doing a lot of the work in this, right? But they've been doing a lot of work. Whenever you have experiments, it makes it way easier. Whenever you can do experiments, like in gene regulatory networks, right? So genes interact with each other to produce, to express themselves in your phenotype, right? Like just how you look or whatever, right? Something that actually comes out into the real world. And people do tons of experiments there. That helps a lot with discovering which genes cause each other. Okay, but starting with, like, implicit in that was that we already know what was a gene. Like we knew the variables in the graph. And so the keyword there is kind of new. So I call it causal representation learning. There might be one or two other names for it. There's definitely one or two other names for it. Like Eberhardt is the last name of, like, one of his students is one of the first people who started writing stuff on this. That's like learning the variables, right? Which you could think of as the disentanglement problem, if you think about it from a causal graph. And yeah, so that's like an emerging area of research. Mila, there's a few people at Mila who are actually doing a lot of work on that, or they used to be at Mila and they graduated. And yeah, so that's something I'd recommend people doing research, interested in like a frontier of research, they should check that out. But so essentially you could yeah, you could learn that whole graph. But then there's not just the variables and the edges, it's what are the functions that map from variables to edges, right? So the causal mechanisms is what they're called. And that's where, like it's nice to use deep learning, right? So it's like you essentially fit for every node, all of its parents in the graph, that's a function for mapping. That's like the input to the output. And you can fit deep learning models there and stuff. And so essentially you could learn all of that, learn causal representation learning. So to learn the variables, learn the edges, and then learn the mechanisms. And then that would give you a world model essentially. And that you could run any question through, like any counterfactual and stuff, if you have all of the variables, right? So then that's where you end up having like noise. So you model some stuff as like, this is unobserved noise. Ideally, there's not confounding, like unobserved confounding. That's where things get tough to do causal inference when there's unobserved confounding.
So I want to get a little more into unobserved confounding, but quickly, just to, because I need this understanding. What's the difference between modeling the parents as a conditional probability distribution compared to this do calculus idea?
Yeah, so for these causal mechanisms, you could think of them as just conditional probability distributions, or you could think of them as conditional probability, but you put the word do in one of the behind the conditioning bar for some of the variables, right? And do there is meant to mean what would happen if I were to intervene on this variable, like I were to physically set it to that thing. And okay, so how is that different from a conditional probability distribution? Well, in regular distributions, you're not intervening on things. You're just given a data set. You're just observing some data, and then you can, through like Bayes rule or whatever probability stuff, you can compute conditional probability distributions. Right, so it's really like the do operator is the more intuitive thing, I think, to humans. We think about intervening on things, and it's actually the conditional probability thing that's less intuitive. Like that's where people, that's why confounding is so important, because confounding will affect conditional probabilities. Like they won't do what you intuitively think they do, the conditional probabilities. But then if you have a do behind the do operator, like do change this action to this action, it will do what you intuitively think it do. Like it'll be measuring what would happen if I were to take this action. And so do calculus, I mean, is a very complicated thing, right? So do calculus is like, how do you get from conditional probabilities to putting do operators in there, because it's like, well, all we observe is conditional probability. We just observe data. We can't say we're not allowed to take actions. How do we get to what calculations do we need to do to get to the things where we're saying, if I were to take this action, this would happen? And that's where do calculus comes in. That's where causal graphs come in to try to kind of inform how you would do the do calculus. It's just like a sequence of operations. And do calculus is very fancy. So it's like, that's the most general way to adjust for variables. So it can produce many different algorithms. Do calculus can.
So at a basic level, would I, if say I just introduce a second conditioning variable, like a binary do variable, and I'm conditioning on that additional 0, 1 do variable, and maybe that conditioning could be injected in, say, like the gain and the scale and shift parameters of batch normalization to shift the distribution such that you kind of know that you're doing and have more layers of control integrated, whether it's like other kinds of normalization schemes to just let this do conditioning variable have more control. Would like a binary do conditioning variable, would that be something that would maybe be useful for, say, like say it's like a reinforcement learning agent and you're trying to, again, learn this transition dynamics model as, say, you're just in like an Atari game and you're saying, I'm going to hit left for like 4 turns in a row to see how that changes my visual observations. Would that additional conditioning variable be enough to sort of simulate the impact of deliberate action?
Yeah, well, so if you can actually, yeah, and so it does get a little bit confusing in do calculus or in Yuta Pearl's notation, right? The guy who made do calculus with his students. Um, it does get a little bit confusing that he uses do um, behind the conditioning bar. But you could think of it as like a totally separate probability distribution. Like think of the do thing as in like the subscript of the probability distribution. That's maybe a more nice way to think about it. And so it's like they're separate distributions. But one is what you would get if you just observed the distribution you have right away. And then I think the thing you're talking about is, well, what if I go and change the program or the simulator or whatever, and I add in this parameter that allows me to change it to like actually I can actually intervene on that parameter. And those are like two different distributions, right? So one is like where you haven't done anything with that parameter. Another one is when you've changed it to 0 or you've changed it to 1. Well, maybe one of those is the same as when you haven't done anything. But those are basically different distributions, and they reflect what would happen in under two different conditions when you do that intervention or you don't do that intervention. And so when you can do that, then causal inference is easy, right? All you do is just run the experiment. You don't have to do any adjusting for anything because you have access to the world model essentially, and you can just run the experiment.
So, in another kind of sense of these world models and kind of transitioning a bit to say, so say with coming back to text data, say we know things like negations. If you insert a not, it should flip the label, or say named entity swapping. If you say it's some specific fact about Chicago and you swipe Chicago with Dallas, you know that the fact shouldn't, like if the question answering system shouldn't produce the same answer. Can we use these kind of data augmentation interfaces as our kind of intervention tool where say our simulator now has the knowledge that if you insert negations or if you swipe entities and the kind of things that are included in say like a checklist kind of system for deploying an NLP model and just benchmarking its robustness, can we use those interfaces to explore causal interventions in our text data?
Okay, so you have a like, is it like a grammar where you can put a not in front of things and then that produces a different sentence or it produces a different meaning? Or
Yeah, and I think that is a good way of thinking about it, just like these grammars and just the formal languages and the kind of idea that you have this kind of pre-computed dictionary of how it should flip the label. But I guess that would be abstracted to the agent. So the agent doesn't see this grammar. It just starts perturbing the original text sequences, and the grammar flips the label when it has flipped the label. So your agent isn't exposed to the grammar. But the grammar is doing the label switching that the agent is can hopefully do the causal discovery of the relationships between the words, because as it say inserts not and then the grammar flips the label, maybe that could inform it on the relationships between the whole part of the text sequence.
so the agent's allowed to say like, hey, I want to put a not here, and then it can observe what the label uh
Yeah, like that kind of strategy.
yeah, well, so basically it's like the agent's allowed to run that you're giving them access to a certain kind of experiment, right? Like where they can so they're always observing this label, and then you're giving them access to a kind of action, like where they can add this not to things and then see what happens. Yeah, and so if the agent doesn't know the rules of the grammar, it needs to learn those from taking actions, right? If you could just tell it the rules, right? You could encode it that's not the deep learning way, but if you were to tell it the rules, then it would have that knowledge too. But yeah, I can learn it from experiments, and that's just generally like to generalize a bit, like that is a thing where um, you're trying to learn causal graphs or or something else. Well, yeah, just say causal graphs from performing experiments, and people come up with algorithms for that. Yeah, so like in reinforcement learning, you're trying to learn, you know, what actions to take to maximize your utility. So it's a little bit different, like the objectives of the thing. But then just to come back to something earlier, it could be that learning the causal graph, like this is kind of one of the hypotheses of model-based reinforcement learning, is that learning the causal graph or some world model actually will help you with your utility objective, which as humans feels like intuitive that should help, right? But it might be it's hard to engineer that kind of stuff.
So one other topic, and kind of coming away from the world models and data augmentation and the idea of learning interventions and producing counterfactual predictions through these world models, is I was curious about this idea on whether you can use causal inference to distill the complex pathways of these giant deep neural networks. Is there a way that we can kind of, we have say 20 layers of computation, and they're wide and there's all sorts of things going on. Could we kind of do causal structure discovery within these activation graphs of these big deep neural networks to kind of compress it into like symbols that kind of explain why it's making its predictions?
Yeah, I mean, I don't know is the answer, right? But like that certainly would be a cool thing, right? So people who say they need to be able to understand the neural network better, and they're not, either they don't know about or they're not satisfied with just like perturbing the inputs and seeing how it changes, sensitivity analysis, perturbing the inputs and seeing how it changes the outputs. What are there's a few tools that do this. I forget what they're called. So it's like for any black box function, they'll do a sensitivity analysis and try to give you some interpretable results. Do you know the things I'm talking about are?
I've heard of a technique. I think the most famous one is called Lime.
Yeah,
What?
Lime and then SHAP and
Yeah, yeah, yeah.
yeah, okay, yeah. So those things. So if you're not satisfied with those things, right? But you want to get you essentially want to like, hey, here's a neural network. It has all this. We've taken all this information from our data set and injected it into the weights of the neural network. Great. Now the neural network's useful, but like I want to understand. I want to, I see the data set and I see stuff. Now I want to go and look at the neural network and see that same stuff, like pull the objects out of the neural network and stuff. Yeah, I'm not sure if someone's tried to do something like that, but yeah, maybe it's like rather than doing causal representation learning on a data set, you're doing it on a neural network, right? Like you could view the two as similar, right? You're basically trying to pump information from your data set into your neural network over the course of training. Yeah, that'd be cool. That would be a very cool thing to do. It sounds like a cool idea.
Yeah, that kind of idea of like abstracting it into your, like say the teacher student, and the student is like the inference network and the teacher has like information about the student network. Maybe it's used to train it, has been the most common thing, like meta pseudo labels, teaching with commentaries, massive list where the teacher is labeling the data or augmenting it or doing something. But the idea that the teacher has the compressed causal structure of the student and is used for that kind of interpretability. So I think we've touched on a lot of interesting topics around causal inference, and I think we could go on and on about all these different things and thinking about what it might add to deep learning. But I'm really curious about Oogway AI. Can you give me the overview of what it's about?
Yeah. Well, and so to draw a line from causal inference to Oogway, so Oogway is about helping people make better decisions. And the line there is I think something that I mentioned earlier. It's basically just the decision that you want to make is one that will give you the best outcome. Well, at least for me. And anyone could say what their outcome is, right? People could have different ideas for what is the best. And so causal inference helps you figure out what action will lead to the best outcome, right? Anyway, so yeah, so Oogway is about helping people make better decisions, and essentially like so where people here, there's like an app for I guess a consumer app that we're building that will help with that, and it's supposed to be for all decisions, right? So I know that sounds like academics will use the word ambitious, right? Which is negative I think to say. But yeah, so we have some ideas about how to actually make this feasible, which I can get into. And but one other cool thing about Oogway is just where like I call it company 2.0. I think there's going to be a next generation of organizations coming, where basically when the concept of a company was invented, I don't know when, like 1700s or 1500s, whatever, that was, we kind of take it for granted now, but it was a really valuable concept that produced lots of value for the world. And I think that it might be the case that we're getting to the next level of that concept, like say company 2.0, which I can talk more about. And so Oogway is trying to be one of those early organizations that are like that. And the idea is like, it would be cool if everyone could feel like they're not wasting their time very much. They're actually like maximizing the amount of value they're producing from their time, maximizing their interest in what they're doing. Like people who want to learn new skills can go and learn new skills, and just generally, like, people care much more about empowerment in our generation than like 1 or 2 generations ago, or sorry, fulfillment, being fulfilled, self-actualized. So I think that there are some tools that can help a lot with that in this next, if this is the next generation of companies. And so Oogway is trying to have all that stuff. You can't maximize all those things, but there's some trade-offs, of course. But yeah, we're trying to, that's the goals.
So can you take me through kind of like the engineering architecture of combining these different tools, like combining like a causal inference part of it with, say, the Weaviate search, with, say, the Hugging Face models? And is that the kind of the architecture, is it's like a routing through the composition of different like AI as an API kind of things?
Okay, so the architecture for this, in the first image here, basically you can see that there's a consumer on the left, and then there's developer on the right. And essentially you can think of developers as putting all these apps into a sort of like app store like thing. I call it App Store 2.0 for similar reasons as Company 2.0. And basically the user is going to see some unified interface where they're routed at any given time, they're routed to the sort of AI decision app that is most relevant for their given decision, right? So you could start off with, let's say I cared about deciding what restaurant to go to. You could have an app that first is just a general search app, right? So it's kind of horizontal. So in the second image here, it's horizontal in the sense that it works for everything. Like Google is a general search app. And then you could later on be routed to a different app that's, say, focused on restaurant decisions. After it's gotten the information from the search. And yeah, so different apps here, and they can have different scopes. So they can be across everything, like horizontal, or they can be narrowly focused to just one thing. And the reason that we decided to do this, so initially we were looking at like, initially the plan was like, hey, AI is getting way better and better. GPT-3's got this cool stuff. And so we tested it out, and it's like, okay, it's cool, but it's kind of like a novelty thing where people like it initially, but then it doesn't really solve their problems well enough to be a good product. And so then we started developing more specific stuff, that involves actually fine tuning the models. Once you fine tune them, you can get pretty good stuff. But then that takes developer time. So the kind of realization was like, okay, to get good enough quality for a lot of decision apps, you have to have some non-zero developer time. And so so that's where we're like, okay, let's try this App Store model. And over time, we can automate like more and more of that. It can be so that it requires less and less developer time. But then, like, does that look attractive to developers? If they're spending less hours, they might be worried about compensation. So that's where it's like, well, you have to compensate them in equity, like ownership of the company, right? So then as AI gets better, it helps Oogway be better and helps increase the value of Oogway. But because the developers were at least partially compensated in equity, they're kind of hedged against the idea of like AI making it take less and less time to develop these AI apps. And also, it's like, okay, well, you need a huge uh, developer supply to do all that stuff, right? To cover all decisions. And so the insight there for like why this is kind of good timing is I think that the AI developer supply is kind of expanding to the software developer supply, which is like a larger supply, right? As we get tools like Hugging Face and Haystack that helps with search, and OpenAI, as we get more in tools like that, it just makes the barrier to entry for AI development much easier, and kind of can expand it to general software developers, which we're starting to see a bit at Oogway with like people who are not AI experts developing AI stuff too.
Yeah, I think this is an extremely exciting idea. So to first, let's try to like just to kind of unpack each thing. The first thing I
Yeah.
want to talk about is so these big models like GPT-3, and maybe we can use prompting to try to get it to do more tasks, or we can say what they're really doing is the mixture of expert style of, say, like the latest GLAM model with the trillion parameters from Google. It's looking what they want to do instead is have kind of sparse routing activations instead of one massive dense architecture. And so something that I've been really curious about, and it looks like you're already set in motion on doing this, is applying that kind of mixture of experts kind of layer on top of, say, the Hugging Face models API, where I think they have like 25,000 models that are probably more. Actually, I don't know. I think probably around 25,000. But the idea like of having a layer on top of that that learns how to route classifications into the Hugging Face model, like the hosted models, and then that's probably maybe is that more powerful than GPT-3, or what's the comparison of that kind of idea compared to prompting in GPT-3?
Yeah, that's really cool. Yeah, we call it the routing team at Uruguay, right? So like, who's in charge of like routing stuff? Uh, yeah, I mean, it certainly seems that, right? Like, take the Macaw from the Allen AI Institute. They're supposed to be GPT-3 at kind of general purpose question answering. So certainly, if you, and like that's on Hugging Face, right? So yeah, so that's just one example of where if you routed everything to GPT-3 but question answering stuff, you route it to like Macaw, say, then this is one example, right? There's probably other ones. Then it should be better than GPT-3.
So something that I'm really excited about building out at Weaviate is our vector search demo API. So right now we have Wikipedia, Wikidata, and news publications, and I'm working on adding the Keras code examples and Keras API reference as search APIs. So similar to querying a model and just getting an inference on, and we have, say, the T5 that unifies every task, supervised learning task, into language modeling kind of, so you can have this one interface for querying the 25,000. I have no idea if that number is correct, but the X amount of models that are on Hugging Face. Similarly, how does that generalize to, say, not just querying a model for its inference, but for querying a search engine where each search API, you can have the different retrievals. So you can have TF-IDF, BM25, SBERT, different ways of getting the representation from SBERT. You can have prompt BERT. So you can have like this stack of retrievers, the stack of re-rankers and further processing, and you can have symbolic filters into the retrieval. So how does the transition, I'm sorry, this is like going off a little bit, but the transition from a mixture of experts over the abstraction layer on top of models to the abstraction layer on top of search APIs?
Okay, so you're talking about the things that you're retrieving are models from Hugging Face, right?
Yeah, I think
Like the
that's another way of looking at it, is you could structure this task as retrieve and read, where you're retrieving Hugging Face models as and then re-ranking the models further, like with that kind of coarse grained and then fine grained stage one, stage two processing pipelines. And that's definitely another really interesting idea. I guess what I'm getting into more is, so like the idea of, say, information augmented models that query like document indexes. So like, say, the Cord 19 data set from the Allen Institute, where they have 140,000 papers related to COVID-19, supplementing it with that knowledge store. So the idea of the abstraction layer on top of Weaviate vector search APIs is you have the Cord 19 corpus, you've got, say, archive, PubMed, Wikipedia, Reddit conversations, Twitter, and they're all in separate search APIs. And so you're the orchestration layer is going, how do I want to route my queries to these different information sources compared to the other idea, which is these different, like say like compressed brains for the model inference.
So, okay, so you're talking about like you're doing, like a search engine, right? Where there's various components, right? There's retrieval, re-ranking, and stuff. But the routing is happening to the data sets, right? So rather than just within one data set, you're essentially finding the relevant documents. There's a layer before that, right? That's routing to the data set. Okay, so sorry, I think I understand that.
Okay, so as we think about building these like meta abstraction layers that orchestrate like it's sort of like, instead of trying to put an entire data distribution in one model, we break up the information sources into different APIs, and then the Oogway layer is, you know, is the thing that routes through it and says, here I've went and searched these specific knowledge sources, and this is what I've produced, kind of.
So so there's models, but then there's also information sources, right? And so I guess so I haven't thought a ton about this, right? And it's like, not that I'm the main one who will be implementing the search stuff, but the way I thought about this was that this is like the search app's job, right? Like that they're doing search, right? Trying to do Google like stuff, and because Google's trying to do this stuff really well, right? And probably succeeding reasonably well. Like it's probably non-trivial to improve on Google. But yeah, so all this stuff about like routing to different information sources, in my head I think of it as like one app, like a search app, but maybe it could make sense to think about as sub apps, maybe, right? Like I'm not sure. But yeah, that's how I think about it. Oogway, and it's like the search stuff is then just like one step in the decision-making pipeline, like one flow of that you might do in decision-making is I search for stuff, I filter it down, and then I have some options and I evaluate the options, right? Like that's one example. And in that example, search is kind of like the first step. So like a common thing with Google is people will go to Google and then they'll click into the first link, they'll skim through it, click out, click into the next week, skim through it, click out, right? And there's this like process of downloading tons of information into your head that you'd think probably you could download this information faster, or you could be targeted to this information faster. And that's all about improving search. It's just getting that information. But then you have to like grapple with that information. So if you're looking at products to buy, you have to think, I have to remember, oh, what was that product I liked that I read in the first link when you're reading the third link, and you're trying to evaluate them, but you have to click back and forth between the two. That's because Google's focused on search. So you could have an interface that helps more with those other steps. Sorry that I kind of went on a tangent after answering the initial thing.
So I guess the kind of the analog I'm trying to make is, say, we went on this transition where you compare GPT-3 to, say, a mixture of experts over hosted models on the Hugging Face Model Hub. And this idea of mixture of experts is so exciting because this attention operation, it's differentiable, it performs this differentiable routing that is causing this boom in mixture of experts. I'm trying to make the analog that, say, from GPT-3 to the Model Hub, Hugging Face Model Hub, is equivalent to Google to these Weaviate or these search APIs that we're trying to build with Weaviate, where you have a collection of different information sources. And so you're routing through how you want to query these different information sources, compared to the task similar to GPT-3 of trying to compress all the information into one API, which is maybe too grandiose and requires this. I mean, I guess like the point of Google is doing this kind of orchestration layer, but I think as you kind of fine tune it for decision making and for personalization, it has a different kind of flair to it. But so one other question I want to touch upon, and as I'm looking at this architecture, is this human in the loop, human computer interaction. And there's a lot of really cool papers that are coming out about how people are using writing assistants, chatbots to help them write, what kind of specific things they're using. So what kind of like, how does human feedback kind of play into this loop for routing between the different AI apps as well?
Yeah, well, so we think of Oogway as it helps people make decisions. It doesn't make the decisions for them. Um, Maybe in the future, there'll be a subset of people who, or for a subset of decisions, they want it to be made for them. But that's not really something we have in our sites right now. Or like maybe in the future, you want something to like automatically schedule your calendar for you, or something, and you don't have to worry about it. Like I think there's actually an app called Motion. I think that's or a company called Motion that they're trying to do that. But yeah, so it's just helping the person, right? So for example, I'm trying to figure out where to move to right now, and I care a lot about climate stuff, right? So I look at maps of sunlight hours. So it's like a US app, and it's a heat map of the US for sunlight hours. And then I do the same thing for like snowfall. Like I want some snowfall, and for the maximum temperature in the winter or in the summer. I don't want it to be too hot. So for a user like me, the idea is like it gives me that information. And then maybe I could also tell it like, okay, I've identified that I have these 3 constraints that I would like, or these like 10 constraints. And then, like I want this snowfall above this amount. I want sunlight hours above this amount. I want maximum summer temperature below this amount. And it could also take that and say, okay, here's a place that satisfies those. This is like for me for choosing where to live, but for other people it might be different. They might want different information, and they might have different criteria. But the idea is that they could give the criteria to Oogway, and then Oogway helps them see how the different options rank according to that criteria. So like a common thing if that people might do is they make these tables where they have the options in the rows and then their criteria in the columns, or a transpose of that. Yeah, and that's like a very simple thing that you could think where it's like we could build those tables for users if they want those tables, right? Not everyone wants those tables, so it might look different for them.
Sorry, I think it's gonna hit the mute. So I'm thinking about this kind of idea of this application of trying to find the perfect place in, let's say, like the United States that you want to live based on the climate. So I'm thinking about this routing between these different APIs. And so with the Weaviate search engine, what you could do is you could say one of these APIs is like all of Reddit data, and you can give it the symbolic filters, the symbolic text filters that discuss climate and that are discussed in the United States, but maybe you want to match those regular expressions for the symbolic filtering for the retrieval. And then you could prepend like a chatbot that takes that kind of information and is maybe personalized to this user. Is that kind of the thinking of just like, so you take the Weaviate Reddit API to retrieve information about this particular kind of idea of, I want to have some sunlight, some snowfall, and then you have some kind of maybe like a reasoning model from the Hugging Face Model Hub that maybe has been fine-tuned on some task of in-domain data where about weather conversations. I don't know if such a data set exists, but is that kind of the thinking of routing between these different kind of like open source AI as API kind of tools?
Yeah, so I think that sounds right. Like so the user might be taken to like a Reddit conversation that's relevant for them. Is that the kind of thing you're thinking of?
Well, I guess so. I guess what I'm thinking is we're decomposing this task into 2 parts where we use the Weaviate Reddit retrieval to get like 50,000 of these conversations, and then we further pass them into a re-ranker that compresses it down into the salient points, like maybe like an abstractive summarization model from this massive context or something, and then maybe some other kind of chatbot layer that you're just kind of plugging in. You're just like API
Yeah,
requests from.
yeah, absolutely. Right. Um, so my co-founder Federico, he built a thing that goes through several of those steps, where he's like doing search, and then he's extracting things, and then eventually trying to summarize them. Um, and and yeah, so the idea is that like a developer could go and develop whatever they want, potentially with help from this sort of like core tooling, right? So there's all this nice core tooling, right? Like, so there's Hugging Face, there's Weaviate, Haystack. So we want to like use all those, you know, we don't want to build our own versions of those, I think. But then there's places where, so we were using Haystack, right? And we were having, like, it's just not as easy to use as Hugging Face. You have to handle hosting and stuff. And so we were building our own like hosting stuff. I'm like, well, let's just make this an API call, so that using Haystack feels like using Hugging Face for any developers that decide they need search stuff. But yeah, so people could string together whatever they want, and then basically the developers can get direction from users. So like you don't take solutions from users, right? You take problems from users, and then you try to figure out a solution. And then we have some like product people who like interface, like, oh, here's what the users are having problems with. How do we solve this problem? And like AI people are like, oh, there you go. And it's yeah, but so search wise right now, we don't have anyone. So we're pretty young, right? Oogway launched its Discord maybe like 2 weeks ago. It's just kind of this decentralized community building this stuff together. And yeah, so it's basically open where anyone can see like what's going on and stuff. I even thought about putting a search on top of Discord to better help people understand like what, you know, so they come in, they're like, what's going on here? Who do I need to talk to about X? And then that's where like search is relevant for putting that kind of stuff on top of Discord. But we're young, we haven't built that stuff yet. But yeah, everything is like open source. It's supposed to be people can help. They can use tools from open source, and then they can also push back out the other way, where like we have a say we have a thing that makes Hugging Face or Haystack easier to use, then we would have that open source for anyone to use.
Yeah, so let me quickly point on two things, and then I want to get into the this decentralized startup idea. So the first of which is, so we interviewed Malte Peach from Haystack on the fourth Weaviate podcast. I don't remember what number it was, but so they have the DeepSet Cloud GUI. Did you check out that with respect to setting up the APIs with Haystack?
Yeah, so I think they were in like beta, and I looked at their beta, and it was like it didn't, like I wanted to not just do I think they were doing like search plus question and answering, and I wanted to just do search or something. It's basically something I could do with their Python library. I couldn't do in their thing at the time. And then when we asked them about scale, like how many documents they could handle, it was basically like they weren't planning to handle a large amount of like over 10 million documents anytime super soon. So we had to host it ourselves and stuff to handle like more documents and yeah, but you know, maybe in a year then they'll have solved these issues, right? It's just kind of like a timing thing that they might be too young.
Yeah, and I think trying to help people understand the combination between Weaviate and Haystack and Jina AI and how these different things plug in together. I think that's one of the core goals of this podcast and this content, is to try to figure out how these things fit together. And so, yes, I think if you just want to use search and then you want to do further Python processing, I think Weaviate alone might be what you need, because it has that kind of Python client where you can still just do the get the nearest neighbor kind of filter, and then further process it with that. So then the second thing before going to decentralized startups is so we've partnered with Katie. They've recently integrated a question answering system into our Slack. So similar to what you're describing with Discord, where you have a question answering in Slack. And yeah, this idea to me is so exciting, like duplicate question detection. I know in our Weaviate Slack, I'm probably asking questions that just make me look like a rookie, because I can't find the exact question when I do like the current Slack search. And so this idea of trying to get rid of asking duplicate questions alone, I think like just the burden on open source software development and getting new people, I think solving that alone is huge. But I love that idea of adding question answering to Discord, Slack, community, group chat. So now let's talk a little more about decentralized startups, because I'm really curious about your thinking around this, and like like this tokens and what's DAOs. I don't understand any of this. I'm just kind of curious about how you're thinking about this kind of idea.
Yeah, well, okay. So on the whole, like crypto stuff and DAO stuff, I know a lot of people will be like, ugh, gross. So I'm not like dogmatic, religious about that stuff. It's just that we had a problem that we were running into, namely that the non-zero developer time problem per decision, where the solution was some crypto stuff, right? Where we can essentially put in a program like equity compensation, and you can make it so that that program's not going to, you can trust that it's not going to change a bunch in the future. Like it's a common pattern with some past startups, some tech companies, where in the beginning it's like, hey, everything's free, everything's great, and then later on they're like, well, hold on, we have all these shareholders that we need to maximize profits to. The shareholders are not necessarily the users. We need to extract as much value out of, for like companies where the business models are ads, the users are the ones, like their attention, they're essentially selling their attention, right, to the advertising, the ad company, the ones that are running ads. And so, they're trying to extract that value. And so when you can make it so that you don't have to worry about the organization like changing like that in the future, where it goes against like users say. One, by you can make these things hard to change, right? So like when you think about setting up governments, like the United States, for example, they tried to make it so that it's hard to change, right? Like the president, especially at the beginning, was not supposed to have too much power. Nowadays, people might think they have more power, but they still don't. It's not like they're a dictator in terms of the amount of power they have, right? Like in the beginning of the U.S., I think there's some story about where I think George Washington would answer the door to the White House himself. There wasn't like someone else to answer; it was just him. Just to give an idea for that stuff. But yeah, you can put checks and balances in companies as well, or future organizations, and then you can set up incentives such as like, who are the people who are making decisions, who are the the shareholders in modern companies. It's like, well, that's just whoever like has decision making rights, right? So like equity plus like governance stuff is, I think, how you commonly see it allocated in modern companies. But you can get those governance rights, so for making decisions in the organization, and just give them to whoever, right? So if you want it to be that one third of it's allocated to users, then there you go. And then that's very different incentives from companies where their users are only like 0.1% of the shareholders or whatever, right? Especially because the users are probably not, don't have very much money. So they, it's usually people who have more money are able to control more in the shareholding votes, right? But yeah, so in short, we can make it hard to change. Like you can put out a smart contract, right, that encodes the equity compensation, and then you can make it so that when there are changes, it's the incentives are aligned. It's not just people who want to maximize profits, but it's also people who are actually using the product. So if the people using the product don't want to, they're not in favor of this super big, like extracting tons of value out of them, then that can, you can set up incentives that way.
Yeah, I can definitely understand that, the idea of the users adding value to the product, or even aside from AI, just like network effects from things like, Twitter, LinkedIn, Facebook, YouTube, like just the general idea that you create the content, you're what's making the platform valuable, and that idea of shared ownership. And I think with AI systems, it's going to be even more like even more on the nose about that, where you're creating the data that you use to train the model to replace you almost in your role of the network. But like, so just kind of this idea of organizing companies this way, but when you have like a decision, like a vote is to be made, like who poses a decision worth voting on? Is it like a Reddit forum where you say like, I propose the acquisition of this company, and then it's upvoted to the top. So now we're gonna like vote on this acquisition deal.
Yeah, well, so I think so. People have heard of DAOs a little bit. It's supposed to stand for Decentralized Autonomous Organization. It's not a very accurate name, right, for a lot of them. But a lot of the ways they have been deciding this stuff is they have it looks just like regular public companies to me, like where it's the amount of shares you have that you bought, right? So it's proportional to the amount of money you have, is how much voting power you have. Yeah, I mean, this or then the other one is one person, one vote, which looks like a direct democracy. So one is like I forget what the word is, where it's like wealth, like a plutocracy maybe, where it's like your voting power is weighted by your wealth, versus direct democracy, or both the models that people are using. I mean, this might sound bad to some people, but I think both of those are clearly wrong. Like especially like direct democracy, I know is like a popular thing, but it's that's a good way to get mediocre decisions, I would say. So there are Pareto distributions and people's competences, and competences is a different thing. So for a given decision, there might be like one or two or three, some small number of people who are like they're going to make a way better decision than anyone else. And so this is part of the company 2.0 stuff. We haven't done this, we haven't succeeded at this yet, but we're trying to set up a system where you're able to select out the most competent people for a given decision. And it's probably not going to be the founders for all the decisions. And then you can let them make that decision, like potentially in a small group. And the Pareto distribution premise is kind of like a big thing there. And why do you want that? It's like, well, if everyone has some equity in Oogway, the better decisions Oogway makes, the more value Oogway will create, and the more value it will be. So it actually helps everyone, for all like people as part of Oogway, for the best people for a given decision to make that decision. And yeah, so this is a thing that we're working on now. It's a very hard problem, but I think there's new tools coming out that make it easier than it was in the past. Like modern companies look much more like autocracies, I guess, or like the CEO, but then I guess there's a board, right, who controls stuff. So it's more like oligarchy like. Yeah.
Yeah, I'm really excited about like also just like AI education tools, and even it doesn't have to be like super AI, even just like YouTube videos that are distributing more information to kind of supplement the democracy, one person, one vote, rather than the concentration around the experts who make all the decisions. I think having just better education tools, whether it's like an interactive kind of Quizlet style thing where you ask them questions and they, this kind of whole system, and then like you earn tokens to kind of weight your vote further by doing the education, I think could be an interesting idea. That kind of thing. I'm just like, I've never thought about this before, but that kind of thinking. But so one other thing with this that I want to talk about is like, what about like the laws around accredited investors? Do you think that's just like, is that a law that's trying to protect people from, foregoing their salary and then taking these tokens that might not be worth anything? Or is it something that you think is maybe preventing people from participating in startups, say?
Yeah, well, so accredit, just for people who don't know, accredited investor, basically means you have $1 million in net worth, not including your home, or it's something like you've made $200,000 in salary for the past like 3 years, or something like that, right? It's all about how much money you have or make. They're adding some stuff about like weird tests you can take that look like certifications that traders get and stuff to become accredited, but that's really not how most people are going to be, like most normal people are going to become accredited. So it's really about wealth. And the idea from the SEC, so that they're the ones who regulate whether you can buy ownership in a company before it's on the public market. So when it's private, so they say it's about investor protection. They're protecting people from making bad investments. It's a little bit weird that you can't become accredited from some more like knowledge-based thing then, if that's the case. But so that's it. And there's, but if you want to be compliant with the SEC nowadays, there are exemptions that you can use. So if you like, when companies raise venture capital, they're often using the Regulation D 506 C or B exemption, and that allows you to raise money from venture capitalists, basically, and angel investors and stuff who are accredited investors. But if you want to raise money from non-accredited investors, like just regular people, you can do that under Regulation CF for crowdfunding, is what it's called. You can raise up to like $5 million and stuff. But there's other rules that make things, like rules around advertising, not being able to publicly advertise stuff, that make things difficult. So that's why a lot of crypto people end up just ignoring all of the rules and just doing their own thing. And they'll become like anonymous so that the government won't know who they are, I guess. I don't think it's that hard to de-anonymize people, but they think they're anonymous at least. Yeah, I'm obviously not anonymous.
So we've talked about a lot of topics, from causal inference and deep learning to Oogway AI, the decision-making layer, orchestrating all these different AI as a service APIs, and talking about decentralized startups and thinking about how the future of company 2.0 and organizing companies is going to be with the advancement of these AI tools. And I think of AI tools, particularly, I think NLP tools are going to have a massive impact on the way that we organize these companies. Things like question answering systems in our Slack chats, and just the way that we can trade information with each other is also interesting. So just kind of one last question. I'm curious about like your information diet and kind of how you're organizing your time between, are you, like running a startup, are you mostly putting out fires and building new stuff, or like how do you weight doing that and then say like knowledge discovery, reading papers and doing the kind of scientific experiments? What's kind of like your strategy for kind of continuing to develop your knowledge and build this tool?
Yeah, so I guess I try to figure out what are the most important things for me to spend time on. I make sure to spend time on those things. Like recently, I had to learn a lot about legal stuff, but also just my personality. I need to be learning about just like random stuff. So I'll often just be learning about random stuff that it's like not obvious that I should be spending time learning about that at that time. Yeah, so I think that's it. I do, I AI stuff, it's like I read it if I need to be reading it, or if it just like has randomly caught my attention, I guess, is when I'm looking at AI stuff.
So how often do like when they say the new paper tweets that are coming out so frequently, how does that kind of like, and I have that same kind of tendency of just like being curiosity driven, and you feel like you need to read it just because it's gotten your attention. How do you kind of like put the blinders on that kind of stuff and stay focused without getting too caught up in all the latest headlines that come out seemingly every day?
Yeah, well, okay. So when I guess when you said the phrase putting out fires, when there's fires, it's not so hard to have blinders on, I think. Um, yeah, some chemical thing in your brain makes it that way. And then when there's not fires, I don't know. I'm like I'm a fan of kind of like maximizing motivation, and it's a little bit radical, but like I think that discipline is maybe a bit overrated, and that motivation's or natural curiosity is underrated. So I just kind of, I'm more just go with the flow when I want to be looking at stuff. But yeah, I mean, you need, I think, different, like a diversity of people on that, right? I think you need people who are more like, they're really good at focusing and it's hard to distract, like you can't distract them, and then people who are more all over the place. I think you need diversity in an organization of those kinds of people.
Awesome. Yeah. So thank you so much, Brady, for coming on the Weaviate podcast. Loved hearing about Oogway AI. It sounds like such an exciting project, and hopefully you come back on the podcast to discuss the update of it in a few months. So thanks again for coming on the podcast.
Thanks, Connor. Thanks for taking the time.